In this lesson, we'll talk about the various heat equations that are used to make calculations about heat energy. The first example involves when you are changing the temperature of a substance. So if you read a question and it's asking you how much energy is needed to change the temperature of this substance from certain degrees to a certain other degrees, there has to be two temperature values given. You would need to know the mass of the substance, the change of temperature represented by delta T, and the specific heat of the substance. If the substance is water, we have a standard specific heat that we can use, but if it's anything else, you need to be told what the specific heat is. The equation to solve this looks like this. We call it the MCAT equation. This value is Q, which stands for the heat energy in joules, set equal to the mass times the specific heat times the change of temperature. Please remember to find the change of temperature, you take the final temperature minus the initial temperature. In this calculation, you may come up with a negative number. That's if the final temperature is lower than the initial temperature, you would actually get a negative delta T value. That would lead you to have a Q value that's negative. And if that happens, that means again that it's an exothermic reaction. The number will be correct, but the negative sign will tell you that it was releasing that amount of heat. If your Q value comes out to be positive, that will stand to be an endothermic reaction. That means the reaction absorbed that amount of heat. Remember from the previous lesson on heating and cooling curves, changing temperature only occurs during a phase, during a solid liquid gas phase. However, if we're going through a phase change like melting or freezing, which is at the same point, temperature is not involved because there is no temperature change to melt. At that time, you only need the mass of the substance and a different value called the heat of fusion. Again, the temperature is not used because the temperature remains constant during a phase change. It is not changing temperature. The equation for that is listed here as Q equals mHF. HF, remember, is one quantity. It's one variable called the heat of fusion. For water, our heat of fusion is 334 joules per gram. That's a constant value that's listed on our reference table. The only other value we would need is the mass of the water or the mass of the substance being used. But again, don't be tricked. The temperature is not used because this is changing phase. The question may even tell you that it's at 0 degrees or it's at a certain temperature. But if that temperature is not changing, you don't put it in the equation. Just because it's at a certain temperature doesn't mean it's involved. The same idea applies when we want to change the phase by boiling or vaporizing. Again, we're going through a phase change, so the temperature is not going to be used. We're only going to need the mass, and this time a constant value called the heat of vaporization. You can see that the equation looks very similar to the previous one, except we change the variable here. It's no longer heat of fusion, it's heat of vaporization. And for water, the standard value is 2,260. Once again, though, we are not using temperature because the temperature is not changing when you boil or vaporize. This is how all the equations would fit into a heating or cooling curve. During your phases, where the lines are slanted and temperature changes, that's when you would use the MCAT equation, because you would have two temperature values. During the melting phase change, you would use the MHF equation, and during the vaporization phase change, you would use the MHV equation. Your reference table gives you a little help with this on table T. It lists all three heat equations for you, and it lists what all the variables stand for. The one to remember, though, is the change of temperature, and in order to find that, remember you have to do the final temperature, TF, minus the initial temperature, TI. and it must be in that order. This will give you a negative or positive when appropriate. The constant values for water specifically are found on the front cover of the reference table in Table B. So you have the HF value of water, heat of fusion. You have the HV value, the heat of vaporization, and you also have the specific heat value. Remember, these only apply to water. So if any other substance is being used, you must be given different values, or you could be asked to solve for them.